Hello, everyone. Thank you for joining us for today's KETIV Virtual Academy session. Today, we have Felix Cortez with us, and he's going to be talking about creating constraints and file management within iLogic. So without further ado, here's Felix.
Hello, everybody. My name is Felix, and today I want to go over these two topics with you guys. Let's go on to the next slide. So with the agenda, we're first going to go over creating constraints, and this includes mates, flushes, inserts, angles, and tangents. Afterwards, we're going to go over file management, and it's just a brief introduction to classes, and then we'll have a Q&A session. A little bit about myself. I've been working with KETIV on the automation team, and I have 5 years in the manufacturing industry. 3 of those years have been doing iLogic and VBNet. I'm a self-taught programmer. I discovered iLogic and I fell in love with it. And I believe that it has a lot of potential to automate your workflow for companies. So why would you want to create constraints with iLogic? Normally, when you tackle on an automation project for an assembly, you have 2 options you can start off with. You can go with a master template where you're suppressing and unsuppressing components or features, or you can start another route where you start with a standard template and you're adding components as the user configures it. And if you're adding components, you have to constrain them in the right location. Also, when it comes to replacing components, if you replace, let's say, 2 bearings and they don't share the same metadata because you downloaded it from a vendor, it might create constraint issues. You might get that red cross, the design doctor. And if you write the program to create these constraints, it can avoid these issues. So let's get started. Here I have this platform, and let's say we have this handrail, and for whatever reason, we want to switch this tube to be a round tube. So let's go ahead and switch this. I am going to get some constraint errors, right? Because this is now round as opposed to the face of the flat face of a square or that shape. So let me switch it back to the square tube, and let's get started on writing constraints on iLogic. So I'll just create a new rule. I'll call this constraints. Now, right off the bat, iLogic kind of makes it simple for us to figure out how to get started. So if I go to this model browser here and I pull down the handrail, I can see what constraints this handrail is associated with. So let's take a look at mate number 1. If I right click and press capture current state, it automatically populates how to write the code so you can make that constraint. So let's reverse engineer this to kind of understand what's going on here. So when we type constraints, we get these methods that we can do. We can add an angle, a flush, an insert, a mate. So for this scenario, let's add a mate. And the first thing it's asking for is asking for a constraint name. Let's call this mate _1. And it's asking for a component. So we're making a component called plate -01 and that plate has an entity called face 0. So this is how we tell which face we're mating that component to. So that's component 1 right here. Now for the handrail, and we're mating some face called face 0. Now down here we have the option of setting a value for an offset. The default value is 0, but let's say for whatever reason we wanted to offset this 3 inches. This for practice. Now we can delete this. The auto generated. I mean, this works too, but let's just get rid of this one. Now, if I was to delete this mate 1, and this component can now move. But if I run this rule that we just created, it created that constraint, and now it can't move. So this wizard here, it really helps out creating constraints. And I want to go over how you can define a face with Inventor. So when you're creating a constraint, let's say you want to create a mate, face and a face, you first have to select one face, and then you select another face of another component, right? So how do you designate a face? How do you give it a name? If you open up, let's say this file right here, if you highlight a face, you can assign this a name. If I right click, well, this one already has a name on it. So let's assign this a name. If I right click, I can assign entity name. And right here, it kind of gives us the default value, but you can name it whatever you want. You can name this top. And you can also do this to edges. So if you have an edge that is very important when it comes to making constraints, you can assign that a name as well. Edge 1, edge 0. You could also assign names to circular faces. You can assign names to points. And I think this ability is only available after Inventor 2019. I believe that's when they started allowing these attributes to be defined. And obviously, you don't want to name every line or every face, just the faces that are important for making constraints. So let me do that. So that's how you can assign attributes to these faces and things that we need. Let's go over another constraint. So this constraint right here is a plane constraining to a point. So that's going to be a little bit different. So let's go back to our rule and let's use the wizard to help guide us. So if I right click this and create constraints, I can reverse engineer this now and try to make sense of how to write this line of code. So let's just start. Let's just go over this. So right here, once again, we're defining the name of the mate, and then we're defining the first component. And okay, what about that first component? We're choosing that plane, and then for the handrail, we're choosing an edge called edge 0. Down here, this is optional as well. So in this, you wouldn't have to write this for this constraint. It's just when it gets, you're using different types of entities, I guess you would call them. The first entity is a face. They call it K no interference. And then the second entity is a point. So that's how you create this constraint for in a situation where it's a plane with a point. So if I was to leave this out, if I was to write a colon here, parentheses, and also suppress this, this wouldn't work if I run this. I guess it does work. Did it work? Yeah, I don't think it worked. Yeah, okay, there you go. There's the error. I don't know why it didn't give me an error the first time around. Let's run this again. Yeah. But now if I unsuppress this, run this, it shouldn't give me an error now. Oh, it did give me an error. Let's see where I went wrong. Let's use the iLogic interface to remake this constraint. And something really went wrong. Yeah, something went wrong when we messed with that. So if I was to re-input this, it won't give me an error now. Yeah, so it changed it a little bit. Yeah, so the initial came up when we tried to modify this right now. We tried to get rid of this. What we tried to do right there was we tried to get rid of this ending part, and that just kind of messed up the constraint itself. So yeah, try to stick with what Inventor guides you with, and you shouldn't have an error like that come up. An error. All right, so let me unsuppress this one. I don't think this one is no good. No. Yeah, so if we run this, then we're not going to get an error anymore. And we can keep running it, and no error. All right, so now this is where some logic comes in. So these constraints are specifically for a square tube. So So we can write something like if type is equal to square, then we would create these constraints, right? Create these. Now, what if, let me change this back. What if this hand row was, well, I'll just say that. Type to ground. We would create a different set of constraints, right? We would create new constraints. Let's switch this out to a round hand row. So right off the bat, we have constraint issues, and we can guess that we might need a tangent constraint, right? So if we create this tangent manually, like this, we can now go back to the rule and use this wizard as leverage. So if I right-click this and do a constraint to add, I can now reverse engineer it and try to understand what's going on here. So we're using the add tangent method under constraints. And first we're defining the name, and then we're defining the hand row, and we're defining what entity of that hand row we want. And then we define the second component and then the entity of that component. And right here, this is a solution type. So if we go to the constraint itself, we have two different solution types, right? We can have it inside or outside. And if we wanted to define that in our code, it's a Boolean. So true would be inside and false is outside. So that's how we can reverse engineer this. Now, if we selected square, we wouldn't need this tangent constraint. It would give us an error, right? Yeah, it gave us an error. If I was to switch this back to this hand row, we get an error, right? Because this tangent doesn't work. So we have to delete any constraints that is not necessary for this square hand row. So right here, delete any non-appropriate constraints. We can go type constraints, delete, and when we're deleting a constraint, all we have to do is just define the constraint name. So we want to delete this tangent. Now, if we run this, it deleted that constraint for us. Let's go back here. Something else I want to point out, then the way you name these, you can only give it one name. So if I was to write something down here, if I was to create a constraint called mate1, and let's say this time it's like a different phase, it's phase 4, and you're mating that with phase 2. And we could even type something different here it could be a different component. Whatever you type down here is going to override this constraint because it has the same name. So you have to be careful of not creating the same constraints and constraints. And yeah, once again, you should use this as leverage when you're first writing or figuring out how to create constraints on how to actually write the code, and you can reverse engineer it so that you can start writing your constraints. And so that was the first topic for this iLogic, for this KVA. Now we're going to go to file management. So when you're going down this path of automation, you might find yourself having to create new files and new drawings. And it's very important that when you create these files, you're consistently sending them to the right directory, and that it's accurate as well. Also, depending on your company, your files have different characteristics. There's certain parts that might be library parts. There's certain parts that might be vendor parts. There's certain parts that are unique to your company, and also other characteristics of that file could be, where does that IDW reside, or where does the flat pattern, the DWG, reside for that file. There's also custom properties. For one company, it's important to know the type of manufacturing process that file will go under. So these characteristics, sometimes you need to know them pretty quick. and you don't want to rewrite the same code over and over and over. So this is where classes come in handy. So let's get started on creating a class. I can right click and add rule, which is called rule 1. Let's define this as, or let's just start by typing submain. And down here below, we're going to type public class, and we're going to make the class called KETIV file. And now this KETIV file has certain characteristics. So let's define some of the properties. So let's say public property. Well, first it has a document name. So let's define path extension string. It also has a location where it's stored. So property path. What else does it have? I guess we can define the property of the file name itself. And now we can also define where does this specific KETIV file have its drawing located. So let's define a new property called property IDW path file extension. We could do the same thing with the DWG. And then there's other custom properties that is very specific to each company. Let's say for every, or very commonly, we need to know if this part is a file that is going to get manufactured by KETIV. We can create a property called manufactured by KETIV, and that could be a Boolean. And the properties, you want to keep it as at a minimum. You don't want to define everything, like maybe the material might be important, or maybe it won't be necessarily important. Whatever you need to automate, and it should go in here. But like color probably doesn't really matter, right? The weight probably does, or maybe it does matter for your company. So what does this look like? What did we just do? If we run this, nothing's going to happen. So let's go back in here. If I define a new variable called KF as a new KETIV file, and if I did a message box and I typed dot, these properties that we just defined. So if I was to display the file, well, nothing's going to show up because we have it set equal to anything. So yeah, it's blank. So let's get started on writing some logic. So what this class will contain, it will contain all the logic it comes to finding the location of the drawing, or a certain type of characteristics that's important to your file. So let's do this by defining a new public sub. So this is initializing it. And when they initialize it, we're going to ask them to input a file name. Now, this gives me an error because we're asking for a string variable here, and up here we don't have one defined. So let's just define something up here. We want to include the extension, so we're going to type true. So now, still nothing will show up. If I run this, there's not going to be anything. So right here, once we get the file. Once we get that variable, we're going to set some properties. So me path file extension is equal to path file extension. We can get the path by typing me path io path directory name. Here we have to input the path extension, and we can also get the file name file system. File name file extension. Now, if I run this now, I will get the file name right there. Sweet. But let's do something else. Let's get the location of this drawing. So let's say in our company structure, we have a folder that contains our components, and if we go up one level and then we go to another folder, this is where our drawings reside. I mean, you could write it up here, that logic, but let's use this class as leverage. So we only have to write the code on this class. So you know what, let me pull something up real fast. I am going to copy this function first. And what this function does is basically you just input a path and then it will return the next level above that. So if I inputted this path right here, it would return this path. So that's all this function is. So let me start by typing me IDW path file extension equal to return previous path. Right now we have this path. Right here. We have this path right here, but we want to get this path, this template path. We're going to input that path. Now, this drawing resides at this folder called drawings. So I'll just copy this, and I will input this. You know what? I am missing something. I need to add this backslash here. So we want. So this drawing resides under this folder, drawings, and right here we're going to input me file. It was an IDW. So now if we go back up here, we could find out where this drawing resides for this document. So if I run this, so now it's displaying this location, template, drawings, and this file doesn't exist, but that's where it would be located. Now that's very useful information. And the point of making a class is that you're handling all the crucial information about the way your company is structured, and you're writing less code here. You're just taking care of all that hard stuff here. You're using this as to do the hard work. And you can also use classes to, let's say, for your company, a lot of let's say truths of a file resides in your customized properties. This is like your source of truth. Let's say you have a property called property 1 and a value of 1, property 2, value of 2. So that's, you could consider that a property of a KETIV file. Let's say there's some custom property. Another custom property. And let's say you want to write the least amount of code so that you can extract that information. Let's create a new sub. On this one, we will call this extract data. And we are going to ask the user to input, or the programmer to input a document. We're going to define the property sets as property sets equal to dot property sets. And down here, we are going to set me custom property 1 is equal to OPS ILM. This. So this right here, user defined properties, that is for custom properties. We want to get the property that's called property 1. We want to get the value for that one, for that property. We also want to do this for the second property. If I go back up here and I want to quickly access that custom property without having to do all this hard work that we did down here, I can run this. And oh, so it has no value. Let's see, why not? Value property 1. Let's go back in here. Did I do a typo? Oh, you know what? Because we did not run the sub, we did not extract the custom data yet. So let's extract it first. So K and KF extract custom data. We're going to insert the document here. Now, if you run this, it should say value 1. So we can get rid of this line of code, but we would have to somehow send a document from new to here. And you know, we can figure out the document by using this path file extension. or we can do something else. Let's just copy and paste this down here. But in this case, instead of inserting a string, we're going to ask the user to, or the programmer to input a document. This won't cause an error, even though you have two different subroutines called new, because this one's asking for a string, this one's asking for a document. So they're a little bit different. Down here, we are going to set this equal to doc full document name. And now we can automatically extract that custom data because we have that document. So we can just call extract custom data and send that document over. So now up here, I would have to modify this. It's we can delete this line. Let's press this one. This we don't want to send the string. This time we want to send the document. So we have two options here. We can send a document or we can send a string. So we send the document. We can see the custom property now without having to. So we got rid of one line of code, and that's neat, right? And there's other stuff you can do with classes, but the main reasons for it is you can also define other properties here. Let's say drawings reside in this location for certain type of files. So let's say like a customer file, we will follow this folder structure. But if you're dealing with library files, maybe you have a different folder structure. And if there's a logic to it, you can write code to figure that out. And you know, up here where you're writing your main code, you can just send information. So let's say you wanted to send, let's say you want to define another variable called KF2, that is new KETIV file, and it was, let's see, you know, you could input a file, whatever it is, the blah 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 file IT. You can automatically extract all that information without having to rewrite this whole routine. It's kind of like a function or a subroutine, but with this class, you have these unique properties when you're returning something from a function. I guess you could return a list, and you know you can extract the information that way. But it's nice to be able to just type KF here, and then you can see the property names, and it actually makes sense. Returning a list is not always that fun. So that was what I want to go over for this KVA. And then we go back to the presentation. Before we get started with the Q&A, all right, let's review what we just learned. We created constraints, and we used the iLogic interface to help guide us on how to reverse engineer the line of code so we can figure out on our own how to write our constraints. We got an introduction of creating classes and why they're useful and how we can create properties in a class. So we have some up and coming events. On June 30, we're going to go over what's new on AutoCAD 2023 and the next KVA. We also have an event where we're going to go over how to use Vault Pro on July 13th. And we also have another event that's more directed towards managers or CEOs on basically how you can use, how you can improve your digital transformation in your company. So now we'll go into the Q&A section. Let me read some questions. Can we get a copy of this code after the stream? I believe so, yes. Let's see. Could you also put that public code as an external iLogic code? No, I don't think you. So what this person is asking for is, can you? I believe what you're. Let me see your name. Let's see. Eric. So what Eric's asking for is if I can create an external role here and create a class, right? created that class like we just did, if I can access it from another rule. No, that is not possible. You might have to, you can create a DLL using Visual Studio, and you can load that DLL onto your external rules so that it's written on one location. That's what I would recommend, Eric. The code, can you comment the lines? It would be handy if there was a comment above the lines with, I'm not sure exactly what you mean by your question, Eric. Maybe it is, let's go back to that rule. Can you, let me go back to that question. Can you, it would be handy if there was a comment above the lines with what the line, oh, I see. So you just a little bit more documentation. Yeah, I guess I should have made some comments. So like this sub is you're initializing as by inputting a string. I believe this is what you're asking for, Eric. And in this scenario, you're initiating this class by inputting a document. You know, you could initiate this class with a double or an integer, but these make the most sense, a file and a document. And yeah, I could write a little bit more notes here. So this sub right here is to extract custom properties of the documents, and it's requiring you to the programmer to input a document in here, or a document. This function right here. Let me show you something else that's pretty cool. If I type 3 lines like this, it's asking me for a summary. So let's just say extract. And if I go back up here to this variable KF, I type KF extract some data. That message that I just wrote right here, extract custom properties, shows up right there. So if I was to update that, update it, and then I go back up here, that message shows up right there, which is pretty neat. So yeah, this video is going to be uploaded on YouTube, so you can reference it back on the KETIV KVA YouTube channel. Hello from Bosnia. Nice, nice. Hello, Bosnia. Any other questions? All right, it looks like that is the end for our KVA today. Thank you guys for joining in, and yeah, this video will be reposted on YouTube.